Hey guys, welcome to another Kant support video. This one's on number of solutions to equations. Let's go. All right, so basically, when would it be no solution? It would be no solution if the variable goes away when you're solving the problem. In other words, you try to get all the variables to one side and they go away, or they cancel each other out, and you're left with a false statement. When would it be exactly one solution? When the variable doesn't go away and you can find out what that variable's worth, right? It's worth one thing. That makes it true. And when would be infinitely many solutions? When the variable goes away, but you're left with a true statement. Okay, so let's just see what happens here. So this is going to be negative 6 times x plus 7 is equal to negative 4x minus 2. Well, this is going to be negative 6x minus 42 is equal to negative 4x minus 2, because all we did is we just distributed that negative 6 through the parentheses, right? And the first thing I'm noticing is that when I try to bring all the variables to one side, they're not going to go away. So this one's going to have one solution because there's no exponents, there's no square roots, right? When we bring it all to one side, we're going to end up with 2x on one side, which means we can solve for x. This is going to be exactly one solution. That's what it's going to be. If it had an exponent on the x, like x squared, or a square root involved, then it might be two solutions, but it doesn't give us that option, right? It's either no solutions, one solution, or infinitely many. And since this is not going to go away, you're going to have a variable that's remaining until the end of the problem. You're going to get exactly one solution. I know that already. But just to prove it to you guys, I'll show you. You add 6x to both sides. You're going to add 2 to both sides. You're going to get negative 40 is now equal to 2x. And then you're going to divide by 2 both sides, and x is equal to negative 20. That's one value, right? That's the one value that's going to work. Okay, so that's the kind of concept, right? Is the variable going to go away or not? If it goes away, is it a true or false statement? That's basically what you're looking for here. So 3 times the quantity of y plus 41 is equal to 3y plus 133, or 123, I should say. Great. So we're going to distribute 3 times y, 3 times 41. When you distribute, what you're going to get there is you're going to get 3y plus 30. 3 times 4 is going to be 12, so that's 120. 3 times 1 is 3, so that's 123. Oh, wait a second. 3y plus 123 equals 3y plus 123. The two sides are exactly the same. Guess what that means? X could be anything, or y could be anything. It's always going to be the same. So I know this is going to be infinitely many solutions. Why do I know that? Because if I were to now write down everything that I have here, not only do I see that they're exactly the same, I also am noticing that if I bring all the variables to one side, I'm going to get both of those variables to go away, and I'm left with a true statement that 123 is equal to 123, which means that the variable is not consequential, right? The variable is going to go away no matter what we put as the value of that variable. It's going to always eventually go away. And that means that you're left with a true statement no matter what the value of the variable is, which means that the variable could be anything, right? Any value will work. So that's why it's infinitely many solutions. Technically, it's all real numbers because it doesn't include imaginary numbers, but they don't have that as an option. So it would be infinitely many solutions. All right, next up. Okay, this one. I think you guys are getting the idea, right? So I'm going to be a little quicker on this one, okay? So this is negative 17y plus 34. Well, that's negative 17y plus 34. Is that the same as negative 17y plus 64? No. Notice the negative 17y is the same, right? Negative 17y and then plus 34. Right? Negative 17y is the same on the left and the right side. But on the right side, you have the 64 being added. On the left side, you're having 34 being added, right? That's like saying x plus 34 equals x plus 64. How can that be true, right? If x is the same value, how can the same value plus 34 equal the exact same amount plus 64? That doesn't make any sense. It's not balanced, right? The right side is always going to be more than the left side, which means that in this situation, when you try to get all the variables to one side, we can see that the variable is going to go away, right? But we're going to be left with something that's completely and utterly false, right? So this is going to be 34 is equal to 64, which is obviously a false statement, which means that there's no value for the variable that's going to ever make this true. This is no solution. And then the last one here that we're going to do is negative 5 times the quantity of z plus 1 is equal to negative 2z plus 10. And we're going to distribute and combine like terms. This one's obvious that it's going to be one solution, but I'm going to show it to you. negative 5 times z, negative 5 times 1. The reason it's obvious is because you're going to get negative 5z. Let's do this in, I guess, orangey color, whatever that color is. All right, you're going to get negative 5z minus 5 is equal to negative 2z plus 10. Well, the reason I say it's obvious there's only one solution here is because there's no way that this negative 5z is going to cancel out the negative 2z, right? When I try to get the z's to one side, I'll be able to do that, and there'll still be a z around. So if the variable doesn't go away, you're going to have one solution in this situation. So that's why I know it's one solution. The variable's not going to go away. But just to prove it to you, what is that solution? You would add 5z to both sides. You'd take away 10 from both sides. And you'd see that this is a zero pair, this is not a zero pair, this is a zero pair, and we get negative 15 is equal to 3z's. You want to undo times by 3, divide by 3, and we can see that z is equal to one value of negative 5. It doesn't ask me what the value of z is, just ask me is there one solution, and the answer is yes, there's one solution. So remember, if the variable goes away in the process of solving, and you look for the true statement, it's infinitely many. If the variable goes away in the process of solving and you left with a false statement, then it's no solution. And if the variable does not go away in this situation where you don't have any exponents and stuff, it's always going to be one solution. All right, hopefully that helps you guys.